go. Okay. So juniors, day one. I'm going to share my screen with you, and here we go. Okay, so today we'll be looking over who engineers are and what they do, and then we're going to be looking into potential and kinetic energy, and then we'll be doing our really cool activity. Okay, so who are engineers? Engineers are people who use creativity, math, and science to solve problems. So there's many types of engineers. We have chemical, electrical, mechanical, civil, and industrial. Now, what are some things that engineers do? So the engineers, they build things, they create things that help solve problems, right? So can any of you think of examples, something like an engineer would do? Do you have any ideas?
One that makes things that help people.
Okay, and what would one of those things be?
Like how, cooking or inventions.
Yeah, so we have rockets and cars, like those are some mechanical engineers would help create.
Electronics.
Electronics, yeah. So that would be like electrical engineers. And we also have computer engineers probably help with that. Did you know that engineers also help with cleaner resources? So we have chemical engineers and civil engineers who help keep our water clean and our air clean. And then we have industrial engineers who help create materials to build stuff out of. And then we have civil engineers building bridges and roads and buildings. Really cool stuff. Okay. So today we're going to be using engineering concepts, and we're using math and STEM ideas in order to solve our problem or find solutions. And so by the end of this YouTube, we'll be an engineer. So some learning, potential energy and kinetic energy. Have any of you here heard of these terms before? Okay, maybe. Okay, so we have potential energy, and this is the amount of energy that is stored in an object based on its position. So this could be from this is from the starting point to the ending point. So sometimes this is if an object is raised up high, it would be from the object to the ground, or you have a spring, and so then this potential energy would be the spring's stretch length from resting position to however far you stretched it. We have kinetic energy, which is the amount of energy an object has because of its motion. What we're going to be doing, we're going to be dropping a marble down this ramp. So it would have kinetic energy while it's moving, because the energy is just the energy it has because of its motion. So for a rope runner, this would be the energy it has, what energy it has because of its movement down the rope. Okay, now we get to our marble tracks. So now, as I mentioned in the beginning, we have two different heights, right? We have either a stack of books or something shorter to put our top of the marble track on. And then we have our chair or some other taller height in the stack of books. Okay. So you might want to do this activity on the ground. I'm going to do it on my desk while I'm presenting. But you will feel free to place your track on the ground. So our first step will be to tape the edge of the track onto your lower surface. I will spotlight my desk so you guys can see what I'm doing. And as you look at these instructions. Okay, so I have a stack of books with me right here. I'm going to just tape the top of my track to the stack of books right here. Each of you should have a little tiny roll of tape. It's blue tape like this, and it's rolled around a tiny little straw piece. Can everybody find your tape? Okay, so I'm going to just take this to the top of my books, like so. And now I've got this kind of gentler slope going on. Okay, go ahead and give me a thumbs up once you have a shorter location to start your track on. Okay, I see one thumbs up. Another thumbs up. Okay. I'll give you a moment to get situated. Okay. See, I can't see all of you, so I'm going to come out of screen share. There we go. Okay, so do you guys have all of those tipping heights? Do you have your track taped on your shorter height? Okay, so I'm going to take my two marbles and I'm going to roll the smaller marble down the track. Whoop. Just like that. Okay, so watch your marble as it's rolling down. Notice how fast it's going. How fast it starts moving. How long it takes to get to the bottom. And you can do that a couple of times. Then I'm going to take my larger marble, this little bead, and I'm going to do the same thing. Awesome. Okay. So what did you guys notice? Which marble was faster? You can unmute yourself to tell me. Was the smaller marble or the larger marble faster?
Mine were both at the same speed.
Okay. Interesting. Yeah, I did notice also that it is hard to tell which one's going faster. So now we're going to attach it to the taller height, and maybe we'll be able to see a bigger difference. Let's see, I'm going to roll my smaller marble down, like so, and then my larger marble. that was interesting. Now, what did you guys notice? Were either of the marbles faster or were they the same speed?
They were like the same speed.
Same here.
Nice. Okay. So that was our little lab. Now, okay, the interesting, so I'm gonna quickly teach you a couple things about like why this was. I forgot to include this, but that's okay. So, an important factor when like looking at speed is like it's the forces that are acting on it. So we have, you ever heard of like friction and air resistance? Well, both marbles have very little air resistance, right? They're very tiny, they have a smooth surface, they're round. And because there is very little air resistance, even though masses may be different, even though their sizes are different, they're going at the same speed because they have the same amount of air resistance. Does that make sense? Okay. So even though while the larger marble has the greater potential energy because it's larger in size, they travel at the same speed because the air resistance is both very minimal. Does that make sense? Okay. So how do you think you can use this when creating your rope runner? Any ideas? Go ahead, you can just speak up.
You can make it tinier because the tinier you make it, the more air resistant it is.
Or the less air resistance. Yes, that is correct. So when making your rope runner, you're going to want to reduce air resistance so that like with the marble, even though they're different sizes, they have minimal air resistance and so their mass doesn't matter. With your rope runner, you want to make minimal air resistance so that its mass doesn't matter as much. There we go. Pretty cool, huh? Interesting how they're both the same speed. Okay. That was all I had planned for activity today. Do you guys want to, we have 30 more minutes left. So I know, right? Timed that a little wrong. So you guys want to make different marble tracks? Like we can like add a loop or something and see how, just have fun with it? Okay. I'm going to stop recording since we finished our informational part of our meeting. Very nice.